Hi, everybody. This is it's great to hang out with all you guys who like robots too. Um, I would guess I'm sort of an accidental robotics instructor. I'm a retired electrical engineer, computer science product manager, worked in the computer industry for years. Um, Retired and ended up working at the University of Colorado Atlas Institute. I guess that doesn't make sense. Retired and working part-time. So I was managing a maker space at the Atlas Institute, which is an interdisciplinary part of the university, part of engineering. Students get degrees in creative technology and design, so very much engineering, but also arts, music, writing, dance, whatever they want to do. So it's a really fun place to work. And middle of one summer, one of Kat's previous colleagues, Brian, comes by the lab and says, "Hi, Wayne, I'm Brian." I said, "Hi, Brian." She says, "Guess what you're doing this summer?" I said, "I don't know, Brian. You're teaching our robotics engineering STEM academy." I said, "What?" "Yeah, I heard you're the good guy." And I said, "But I don't know anything about robots. It's like, computers with wheels." He says, "Perfect." So he talked me into it, and I've had so much fun. I haven't been a K-12 teacher before. I started teaching high school level, and just a blast to do that. I'm now also a adjunct assistant professor at Atlas, so I teach one or two classes a semester. This semester, I'm teaching a class on music technologies. We're building all kinds of weird things that make music sounds. We'll see, lots of fun. Um, so, so with CAT and CU Science Discovery, which is our program for K-12 education, after school programs, summer camps. We do outreach to the state of Colorado to all kinds of schools and help them teach science. We have prepared exhibits, experiments for them. Sometimes we teach them, sometimes we teach teachers. So it's a program that's what, Kat, 40 years, right? It's a long time. And
This
so
is our
it's
40th year, exactly.
40th year. A pleasure to be part of this. And so I taught robotics. This is, I think, several different platforms. And I'll say right away, there is no perfect platform to teach robotics. So the market is open, Petoi guys. Your product is great. It's not perfect. If we have the perfect one, we can all rejoice. And I did start out with an Arduino with wheels, and that's pretty cool. Then Sphero, who is in Boulder, Colorado. I was an early adopter of their Rover platform, which is a tank tread skid steering thing. Beautiful robot, powerful motors, amazing capacity in the lithium ion, no, lithium ion batteries, but it's all built. So some of my students loved that it was a finished thing. Others were like, "Oh, I didn't get to build the robot." And I found that when kids actually build the robot, they have an attachment to it. And that's a really important thing. Now, Kat and I agree that the most important thing about STEM education is, what do you do after the class? So we try to budget things so the kids get to keep their robot. So they build it, they get attached to it, and they keep it. And so much of our curriculum is, what are you going to do with this at home? Are you going to play with this? Are you going to go entertain or annoy your family, most likely? Are you going to use this for a school project? And we don't know. We hope we set this into motion and see what happens. Well, Kat knows because her son was in our camp this summer. So this just recently in August, I taught a 1 week high school level class using Petoi Bittle. I was watching Bittle as the advertisements in it was a Kickstarter, right? Am I correct? How did you first introduce this? Yeah. So I bought into the Kickstarter and patiently awaited the arrival of the early version. And why? Because a robot doesn't have wheels. Robot has legs, right? All the cool robots have legs. So I was honestly a little intimidated to teach quadrupeds, because what do I know about that? That's what the mechanical engineers do. I don't know about leg motion, so I was a little worried, but I'll figure it out. My impression of the leg form factor and the dog with a head is that everybody immediately attaches to this as an organic thing. And it's a relationship that's different from just a platform with wheels and wires. I saw this at the Atlas Institute, I don't know, a couple of years ago. We did some inflatable, programmable STEM things. We had a guy from MIT came out who had produced what he called Pneumo-Duino, so an Arduino with pneumatics. And he taught us how to take sheets of plastic and glue, adhere them together with heat, and make them into airtight pouches. And you can make all kinds of forms that then you inflate under computer control. You have a pressure sensor to see what they do. And you inflate something that looks like a leg. Everybody thought it was alive. So the octopus, the spider, whatever. And the fact that it doesn't necessarily inflate in a predictable pattern makes it more likely to be perceived as organic and alive. And so the attachment is huge when you actually think I'm creating something that has perhaps its own behavior, right? So very engaging. And we all know, when you're teaching STEM, there are some kids, whatever, it doesn't matter what your age, but they love the math, they get it, they really like computer stuff, they're happy on a two-dimensional screen to do that. There are others that won't touch that. That's not engaging. But show them this organic thing can have some behavior that you can design, and they're engaged. So I guess, I like the word, I think it came from NYU, from New York University, of physical computing. And I called these classes an example, an experience in physical computing. So robotics are one of them, but there are many things that are physical computing. So tangible, interacting with the environment. And so that's the way I approached it. And I have found that there are sometimes reluctant students, their parents sign them up for camp. And when we start the introductions, why are you here? Because my parents signed me up for camp. And now I know, okay, am I going to be able to engage this person, right? Because they're not exactly sure. Some of them turn out to be the most interesting students, the best students, because they didn't know what they were getting into. The ones who say, I know C++ and Java and Python, and I've already built 100 robots. What's this robot? I'm going to have to keep them challenged, right? Because they already know this. And how do I challenge them? I give them problems I don't have the answer to. That's great. And I try to engage them in group activities. So one of the things that was really cool about the Sphero rover was that it had really cool IR communication. So very simply, you could say, hey, follow me around. And so my favorite project was a group of young women made a mother cat and her kittens. And the mother cat went moving around our classroom looking for the darkest, quietest space using its light sensors and its sound sensors. And the kittens followed it in a kind of funky, organic way because the communication and navigation's imperfect. Excellent. And then she led them to this quiet, dark space where they all went to sleep for a while and started purring. That was great, right? And then when they woke up, they went to find, with their infrared sensor, a warm human leg and circle around that and also sit down and go rest for a while and purr again. And so that was so fun to see that they could do that in a day's worth of work. You can get that from a very finished robot that has built-in fantastic navigation capabilities. When you say turn right 90 degrees, it gets there even if it encounters a rock or something, right? So it gets there. So that's really cool. But it sort of robs the students from learning control systems and navigation and error management. So there's this trade-off. I want to get high-level behaviors versus I want to really understand the hardware. In a one-week class, it's hard to do all those things. In fact, it's impossible. So let me show you any questions so far. All right. So I'm going to share with you the curriculum I used as the best way to describe my approach to this. And I will go share this screen. And let's see. All right. So here's my Bittle robotics thing. And feel free to, I'll share a notebook in a second, but I'll give you this site in the chat. Come back to me chat thing. Here we go. All right. So that's my curriculum. Feel free to use what you want of this. Easy list of materials for this class. Just buy your Petoi. Actually, we bought it for them, so it was ready and waiting for them when they arrived in the class. And you know, it wasn't the easiest budget for us. Pretty expensive compared to things we've done, but we made it work, which was great. Here's the overall outline of the class. So of course we start with introductions, and you know, what grade are you going to be in the fall? What programming languages do you know? It's okay if you know none. And what do you expect to do from this class? And also where to go to school. So sometimes, because we're drawing people from throughout the state, and it's really fun when people who don't know each other find that they'll be in the same school in the fall. So that's kind of exciting, and maybe they'll want to collaborate. I hope, right? That's my goal. And then we have some fun checking out robot toys. So we have all kinds of robots for them to play with. Spheros that they can drive around with tablets. I have my old R2 voice controlled R2D2 from early 90s, which still is surprisingly interesting. We have modular robotics cubelets, which are magnetic cubes you connect together, and you program them by who they are connected to. And that's an interesting thing to see what kids can do with absolutely no documentation. Can they build something that can sense its environment, like run across the table, and when you find the edge, stop and back up a little bit, right? So that's the kind of thing you can build in a few minutes if you're paying attention. They drive the robots around the classroom, and depending where you are, perhaps down the hallway, and encounter other people, students, professors, faculty doing their thing, and maybe they have those random interactions about, what are you guys doing here? Oh, we're in a robots camp. So I really want to have that discussion going on to see what's happening. So that we all settle down from that. I also, it's a great opportunity for some classroom management, because I can already find the troublemakers who are going to just, I have to have my TAs watch them, because they're going to always do something a little, you know, off center, and challenge, look for the boundaries, right? And then we sit down and assemble the kit. And I'll give you some feedback on that, but it's challenging for some people, and others it's obvious. And what are the problems of this? So I think, as who was saying earlier, Elaine was saying, you know, 2D to 3D. Very clear when you have someone have 2D instructions and try to come up with a 3D thing, which guess what, has front and back and left and right symmetry problems. And if you're not paying attention to those details, your Bittle will be a mutant Bittle, and might break itself. So we have to be very careful about the assembly. So that's a fun thing. And then we, of course, do Hello World, which, you know, Hello World is blinking an LED in physical computing world. And then we go through a series of activities, and we're learning more about the programming environment, sensors, and how to control the robot. And I'll show you more what those look like. But the general shape of this is, here's an introduction to the technology we're learning. A sensor, an actuator, a programming construct, whatever, and an example for them to just either copy or download, and experiment with it, see what it does. And then I give them some time to make it their own. If we're blinking the LED, change it. And you know, the simplest people, the ones that are the least motivated will just change the blinking rate and consider that done. And I'll poke them to say, well, what else can you do? The most sophisticated people will go off and develop a protocol to send a message like SOS, right? And I try to convince them that now you can make an LED link. You can send a message corresponding to any other message that's ever been created on the entire planet of Earth through human history. What? So that's an interesting concept for information theory, that if I can blink an LED, I can send an arbitrary message. And I think that's a powerful concept. And some people look at me like, they don't know what I'm talking about. Others are like, I hadn't thought of that. And they're off and running. So that's really great. And that's not really a robotics program. That's just, I mean, you can do that with no physical computing. You can blink an LED on the screen. But it's very motivating for people to blink LEDs for the first time. And so I'm glad that there's LEDs hanging out on the Bittle platform, that we can do that before we've even try to do any robotics. Let's see. The big change, of course, with Bittle is the skills, the motions of the limbs, the quadruped. And my intimidation was, how am I going to talk about creating stable gaits and things like that? It's hard without doing the math and all that. And so what I really liked is the skill composer that's part of the OpenCat software. And so being able to create static poses with an interactive tool with that actually move the actual robot, and then find out, oh, well, that's not going to work. The thing's going to fall down, or that's not the angle I wanted. And then convert that into a sequence of steps to either create a gait or just sort of some kind of a motion. It was amazingly interesting to the group. In fact, I had not planned on spending as much time as the students were motivated to do. They were so impressed with their ability to create this organic figure their own by creating poses that meant something to them. And I'll show you some quick videos from that. What else? So since we're at a university, we brought in some guest speakers to talk about what researchers, students, what they're doing with robotics. I had planned to bring in an actual Boston Dynamics spot to come visit our lab, to actually just remotely knock on our door and say hello. And unfortunately, Spot's batteries were all dead, and I couldn't come up with $6,500 to replace a battery pack. Oh, do we have a problem with the high end of robotics and batteries? That's a whole nother topic. And then we had a team from mechanical engineering that did a competition and to do an underground exploration of a cave to go find objects. And that was a really fascinating talk with some good videos. And I think the students could see how their work and their learning was corresponding to what these guys were doing at a very professional, advanced level, right? Autonomous robots. But they could see the kinds of problems in sensing environment and navigation and those kinds of things, and how what they're doing is the very beginnings of this. And so some were very motivated, like, well, I'd like to do that when I'm in college. Great, that's the point. That was great. And then, in a week, we don't have that much time for group projects. We spent sort of an afternoon with a brainstorming effort, like, what would you want to do with Bittle now that you know some things about what Bittle's capable of? What motivates you? And can you find any synergy in what other people have in ideas? And we created, a small number of group projects. And as always, there's some people who like to come to STEM classes who don't really want to work with other people. And I try, but I don't push. So some people really just want to work by themselves. A missed opportunity for me. I wish there were ways I could sort of convince the people who are reluctant to do group work to do it, because this is a great platform for that. Build two robots that interact, share ideas, prototype quickly. It's just great. Any questions about my overview of the class? All right.
What was your age group for this?
High school.
High school?
So
and you charge?
Oh yeah, no, they pay for the class.
Can I ask how much? Because you got to cover the you're letting everyone walk away with a Bittle.
You bet.
And so go ahead. I'm just curious to see.
I was going to say
more than what we've done when we let the students walk away with a robot. So
I'm trying to remember what we actually charged for that class. It was more than our usual classes, because we charged like the class fee plus a materials fee, which was mostly the Bittle. And I'll get that number to you.
Yeah.
In a second.
And other Science Discovery has classes for middle school, I think even elementary, using Spike, but Spike is super pricey.
Oh, yeah.
Right. So Spike doesn't leave the classroom. In fact, you hope no parts actually end up in people's pockets. So it's a different model. So we try to get this outlined to parents, guardians, students before their first class, in hopes that some of them will actually get some software installed So preparing them so when they take this home, they have a computer ready to go. And if they have trouble with that, I want them to bring their notebook to class and maybe use that. We supply computers, of course, but we'd like them to use their own if possible. And so this was, not 100% perfect. A couple of people got it right. There's permissions problems and version problems, blah, blah, blah. But we tell them to do that. We also had them install the Arduino IDE because we started with the Mind+ software, which is a yet another derivative of MIT Scratch, block-based programming that many STEM educators are familiar with. A lot of kids come into the class of seeing that before, so that's a plus. Honestly, the first time I tried to teach with a graphical drag and drop programming model, I didn't really like it because I feel like, well, what do you do when you run out of ability, right? You have to now make a total mind switch to a text-based programming language, and are any of your skills reusable? Well, what I like about what happens with Mind+ is we can look at the Python that it's generating, and that's it's an interesting model because the way Mind+ works with the Petoi is it's sending commands over the serial interface, either through a cable or a USB, to tell the firmware, the Arduino program, OpenCat, in the robot what to do and what to sense and that kind of thing. So that's a different model. When I taught with the SparkFun Redbot, which is an Arduino board with motor controllers, you're writing the program. There is no firmware, and that's a deep dive right away into Arduino. So that is a slower start before you're doing things that are robotish, because we have to learn Arduino first, right? So that's that approach. Let's see. Well, let me take a quick look through what my activities look like. So, this was how to do assembly. We've got to go upgrade Bittle firmware. We want to charge the battery. Of course, that's a classroom management problem, is to always find times to get the batteries charged when you're not using them, at home, overnight, in a break. Because it's very sad when someone wants to make their robot do something and their battery's dead, and I don't have a pocket full of batteries for them. And especially, this battery is a pack. I can't just throw in some rechargeable AA's or whatever we do for other robots. So that's important. This is, we followed the instructions that Petoi has provided and just sort of guided them through that. And try to do this together step by step. And of course, that's when chaos ensues, because the abilities of a classroom of, I think, we had 16 people are wildly divergent. Some people are like, no problem, I'll put those little teeny tiny screws together and I'll get it fine. Others are lost, and you've got to help them. I had one student who came with parental documentation about their physical, emotional things. And this was really tough. The same person, when we switched to programming, top of the class. So physical hands-on manipulation, eye-hand coordination, incredibly hard. Writing programs, amazing. So what do you do with that person? They needed hand-holding every step of the way. Thankfully, I had some TAs. If any of you are going to do anything with Bittle, pay attention to all the instructions that say, really, 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 don't bolt the thing together with the legs so it looks like a robot. You have to resist the urge to make it dog-like, because before it's calibrated, it doesn't know where its servos are. And when you power it up and it says, oh, okay, I'm going to go to my resting position, but you're at the wrong rotation, well, then the servos are trying to push a leg through another leg or through the chassis or whatever, and you might burn out your servos, which, guess what? We did a few of those, right? So despite all the warnings, some kids couldn't resist, plugged it in, turned it on, and then you hear zzz, and I said, oh no, and then the servo's melting. So I think, Kai and RZ and I met a couple of times to talk about this, and the next batch of servos was supposed to have some built-in firmware that said, hey, have you been trying to move to angle X for more than so many seconds and you haven't gotten there yet? You're encountering obstructions, so stop, turn off the power, and don't melt your servo case. Let's see. So then this was, then there's this whole thing about doing the calibration. And then once you know you're calibrated, to actually put the screws in and keep the thing in place. So this was an experiment in patience and delayed gratification, right? And some kids really couldn't get that. And I'm sure that's not what they came to robotics camp for, but that's what they got. And, great experience. And this, of course, happens at all ages. I can't wait to get the thing built, and I'll just forge ahead despite the urgings of my instructor. Let's see. Then we moved on to Hello World. So we played with the Mind Plus software, and just had them copy this program. And this was a chance to learn the user interface. Where is that in the menu? How do I find it? And some people it's obvious, and some people you got to show them. So this was an opportunity to say, well, if you figured this out, but your neighbor is struggling, try to give them some help. So this is a good opportunity for immediate collaboration in the classroom, right? So works pretty well. Then I had them explain, what is this? What's going on? And some kids get it right all the time. Some, of course, commit the classic error. They're smart enough to see that there's blocks here that are the same. So they create the digital write high, wait 1 second, and duplicate it because they found right-click duplicate. And then they have digital write high, write 1 second. And they say, my LED doesn't work, it stays on all the time, which is great because they've now invented an opportunity to debug. And I will often have them share that in the classroom to project it on our screen to say, okay, who sees the bug, right? And so this is a great, easy debugging exercise. And of course, I've done this myself countless times and looked at it and not seen the problem. So it's great to have that sense of humility when, but the robot isn't doing what I asked it to do. Yes, it is. And then, like all these exercises, do something else. And if this, of course, were a graded high school class, this would be the homework assignment. This would have a rubric. It would be, bonus questions, whatever. But this is a camp. We have kids at all different levels. So some of them are going to do the first thing. Some are going to go way beyond this and introduce some other challenge for me. So I like to do that. It's a little risky, right? Because, what are they, day one, ask me a question I can't answer about the robots. There's a chance, right? But that's okay. We all recovered. Then that's an example to say, well, here's how I would do my research to answer the question. So I can show them what that is. Other kids are so excited about this idea of blinking SOS, but can't figure it out. So I say, well, try it yourself, but otherwise you can download the Mind Plus program and see what I've done, right? So I also urge them to save all their work and copy these things. The Mind Plus app could do a little better job to find a way to store your things in the cloud. I've taught with another platform called CodeCraft for Arduino programming, which is another MIT Scratch derivative, and it has a cloud-based storage service so you don't lose your programs. I think it's kind of sad when someone puts some time into something and they're proud of it, but they forgot to save it somewhere. So I try to reinforce this, but kids differ in their 21st century skills about where do I save my stuff? Do I put it on a thumb drive? Do I put it in a cloud service? The program itself doesn't really give you an off-platform way to save this easily. So you have to figure out what you're doing. So then let's go through. So we added a external button to Bittle. So because the Nybble controller has Grove connectors, there's a whole ecosystem out there of Grove compatible things. So very inexpensive, a button with an LED and a cable, and we can plug it in now, have external way to control the robot. And this is also another quick intro to some electronics. Some kids know this, some don't. So it's an opportunity to talk about, well, we have wires and the wires have certain functions, and here's a quick way to understand what they do. So this is fun to play with this. And then we just extend the previous program and say, well, when we press the button, we're going to have the LED turn on and let it go and turn off instead of being on a delay. And because people love to make noises, we play with the tone thing. The other trick about having your robot make some noise is, as an instructor, you can quickly see who's at what level. So I start hearing the tones. I can hear we're making it through this. When there's kids that make no tones at all, I know they're struggling, so I can find them. This is a bit of a challenge if you don't know that people are struggling. So and then same thing, do something else with the button, right? Let me just zoom through here. Let's see. We introduced Bluetooth early enough because it's nice to have a wireless robot. So we'd spend some time of how do you configure this and how do you see what works and all that. In a classroom full of kids, they all have different Bluetooth devices, but they don't know which one is theirs. If you've taught using other Bluetooth things like microbit, right? You can prepare the classroom and say this microbit goes with this laptop, and never, don't confuse them. Otherwise, you'll be writing programs for your friend's microbit, right? Here I said, you know what? Let's just figure it out. And we played with since we installed the Arduino IDE, we used its serial monitor to go talk to the Bluetooth board that Petoi includes with the kit and ask it, so what do you think your name is? Very easy, and it tells us. So then when we do the Bluetooth pairing with the operating system Bluetooth stuff, Windows or Mac, then you can say, okay, here's a whole list of Petois you can pair with, which one's yours? And don't be devious and pair to the other guys. That's not nice. So we'll see what happens. So that kind of works. Then, of course, those who are curious and slightly mischievous found the command to change the name of their Bluetooth. And I didn't know if that was going to work or not. So I was surprised. It sort of did. But they changed theirs, not to Petoi 249A, but my awesome Bittle robot from another planet, .7, whatever. So you have to cope with that, and that's fun. But so I like that because robots really don't want to have a wire attached to your computer, right? That gets in the way of moving, which we're doing later. So then we do some head turning, right? We're going to very simple move Bittle's head around, and then some moving. And what's cool about the OpenCat software is the skills, so-called skills, are built in. And you can do these sophisticated motions without knowing the mechanics of quadrupeds. So just go crawl or crawl right and see what happens. I picked crawl because it's safe, it's not going to fall over, and it seems to adhere. It seems to work with the friction on the surface of a table or the floor. And of course, I tell them, please put this on the floor, because if your Bittle walks off the edge of the table and goes boom, it's going to lose a limb. And I only have a few spare parts, right? Despite that, some kids do it anyway. All right. So then we have to experiment with some friction. Maybe we'll put the little rubber socks on that the Petoi folks included with our shipment, so we can see if we need the friction for that, for whatever surface we are. And, of course, if you're going to set this thing up and teach in a classroom where you haven't prepped and experimented, you might find yourself surprised by how Bittle trips over itself on low pile carpet, or how it skates around on a highly waxed tile floor. So this is good because this is part of robotics. How does your robot deal with different surfaces, and how do you tune that? So you may have to go slower. And then we do kind of the real hello world for robots that can move is go navigate somewhere. So walking in a square is one thing we do. Now, one of the challenges with Bittle is you can't say make a 90-degree turn, because it doesn't know. It doesn't have a gyro, and the firmware, the OpenCat software, doesn't have that. So you have to experiment. How long should I crawl to the right by time? And I get some kids asking, like, how do I know how long? I said, well, do some experimentation, right? So they do that, and then they're surprised that not everybody's robot needs the same numbers. Like, well, they're different. They have different frictions. They have different.
Actually, there is a gyroscope on Bittle already.
There is a gyroscope. There is a gyroscope. Not accessible through OpenCat.
Yeah, that's how it knows it's getting flipped.
Right. Well, it knows the accelerometer, so it knows acceleration to the ground. But if I want to turn 90 degrees,
You will use the yaw angle. It has the yaw, pitch, and the roll, 3 angles that can be extracted from the sensor.
well, I should have noticed that. And can I read that from a MindPlus app? Can I get the gyro number?
Oh, that's the question.
That's the
We
question.
only have access to that in the Arduino environment.
Yes.
At
Okay,
a blog.
that's right.
Yes.
That's right. That's my correction. Okay, good. So this my
Can we
comment
add
here
that
is
access?
wrong.
Oh, I see. Can we add the access to that kind of information through MindPlus?
Yes, we can do that. Like for the
Or
whiteboard.
or following what I mentioned with Sphero Rover, include a command that says turn right 90 degrees, right? And let the firmware do that for you, right?
Mm-hmm.
And then you don't have to do the monitoring. Am I there yet? Am I near? Because you can turn a lot faster if you can just say, please go that angle. All right. So that's good. So better navigation. Good point. Okay. This is incorrect. I don't need to add a gyroscope. It's already built in. Thank you. What else? We play with some of the sensors, like the light sensor that conveniently clips into Bittle's mouth through a Grove cable. And we've played around with that, and we can look at left and rights. We played with the gesture sensor. Now here, since this doesn't work at the time with MindPlus, this was a convenient time to give them an introduction to Arduino programming. So we actually now took a flying leap and went from easy MindPlus to much more challenging Arduino coding, and with detailed instructions to do this. And then, this is a lot more instructions to what's to be done, and then how to get this to work, and then do some modifications. So this was a challenge for those who had no coding experience. And, we got people to sort of follow a recipe and get it to work. But those who wanted to make their own cake, need to learn some more things. Some kids did, some kids didn't. So, that's where in a week's class, I really can't do this. If I had more time, it was really an Arduino class, we would dive into this and learn to become Arduino robotics programmers. What else? Let's talk about skills first. Oh, I didn't mention, one of the things I always do with robotics classes, we always have robotic video of the day. We talk about the history of robotics. We look at other examples of robots. And of course, we have to do videos about the inspiration for Bittle, which is Boston Dynamics Spot. So we get to see some great videos. And of course, I like to show them the Rolling Stones Start Me Up video, which most of these kids have never heard of the Rolling Stones, but I have. So you get to see some really sophisticated robot motion. And some of the kids who want to make their robot dance are now very psyched. In fact, I probably overdid it, which is why they spent so much time saying, no, we want to do more skills. So if you haven't played with the Skill Composer, this is a really clever piece of software. And let's see. Do the Love Me video is great too. Do you want to dance? Yes. It's a little tricky because you have to understand where do these joint controls correspond to the various limbs. What's an arm? What's an elbow? Whatever. What's a knee? And does Nybble have legs or arms or both? Well, you have to decide, right? The user interface of this thing suggests. But for some kids, as they play with this, they start to get the mapping from, I have 9 joints, 9 servos, and I can control them and create these poses. And most of them will have Bittle fall on its head. So you have to be careful about balance. So they really love doing this. And then the fun thing is once you create a skill, you can very simply execute that skill with a MindPlus program. So that was really fun for them. And then, as always, go create your skills of your own. And I used one of your videos about Bittle trying to walk over some, chasm created by some boxes. and how the trial and errors were an important part of learning, and to motivate them that, you know, if you don't get it right the first time, do a little bit of tweaking, you'll get it to work. Let's see. And I said silly, entertaining, and strange skills are encouraged. Just don't make Bittle fall down and break a leg, servo. So that maybe made them do too many silly things. Let me show you. I think I saved a couple of videos. Oh gosh, I should have prepped this. All right, you have to see my family's photos. Sorry. Okay, thank you. Where is Bittle? No, where is Science Discovery? There we go. 2023. Okay, good. So here is the class trying to draw a square. Not going so well at first there. We're just learning. Boy, that didn't work out right. Now here's a group of boys who decided their Bittle was a weightlifter. So they found, you know, classroom objects like dry erase markers and tape to make them into, and a straw of some sort to make it into weightlifting. And this is three rowdy boys who were constantly challenging each other physically. And so they decided that's what they're going to do. Bittle is a weightlifter. Awesome. This was our guest lecture about autonomous robots. And I also use this as an example, a little bit example for people to learn how to solder. So we happened to be in a makerspace, the Blow Things Up lab at CU. And so I got them some ribbon cable, gave them a quick soldering exercise, and had them turn their button into a leash, because who wouldn't want to have a leash for their dog, right? So these guys made one long leash and one short leash, and then created some interesting behavior with their Bittle.
Right now it's walking, not this big way.
Am I sharing sound or not? I'm not sharing sound. Let me try that again.
We can kind of hear it, but it's not optimized for sharing.
I will fix that. This is really funny. These people were really quiet, and as soon as we put a camera in front of them, oh, I'm on TikTok. They all of a sudden became video actors. It's just hilarious. I should have realized. I don't know if people have done this. Maybe because we live in this age of the way I communicate is I make a video and share it, that they're used to that, as opposed to standing in front of the class and doing a presentation.
Yeah,
That's more
so
intimidating.
are you sharing the other screen? Because now we only see your desktop.
Oh, sorry.
So the students are sharing the videos on TikTok?
No, I'm just thinking that would have been interesting had I said, and at the end of this exercise, create a video that you can show the class. And I think some kids will be more likely to create a video that they can delete if they don't like it than have to stand in front of a classroom and present. Which I don't know. I'll defer to people who have been teaching for many more years than me about how do you get people to do presentations. But let me just, it's just a quick thing.
So right now it's walking, so not pressing any buttons. And when you press this button, it starts boxing.
Mm-hmm. And when you press this button, it starts the P feature.
Not on me. Nice.
When you hold both buttons, it'll do the cheer feature.
Ah, both buttons. So the logical AND function. Awesome. Nicely done. All right. So so that was a very effective spontaneous collaboration between two kids who were sitting together who really liked the soldering thing. The really funny thing is I taught them how to solder, and I showed them how to use heat shrink tubing, and they decided that they would solder all the connections to the leash and put one big piece of heat shrink over all the connections, shorting it out. So I said, oh, well, let's talk about insulators versus conductors. So that was a fun little mini, physics and electrical engineering exercise. You never know what people are going to do and why that concept wasn't obvious to them. But we rescued that, and then they wrote their program and life was good. And projects. So, building something together is a great opportunity to learn about how do you collaborate, and how do you brainstorm, and how do you support each other in your creative ideas, and how do you go broad to make the most ridiculous ideas, and then how do you narrow to figure out what you're going to implement in a few hours. And this is this is a challenge. You don't know in just a week's class with just a few days. I'm not exactly sure what's going to happen, but it works. It works, and I get them to do some presentation about their idea. Some of them wanted to draw pictures, some of them wanted to use Padlet. I had Padlet set up, but some of them wanted to just describe it. Fine, however it works. My prompt for them is, I want to build a robot that blank because blank. And I try to create this in the context of something that's social emotional. So why do we build a robot? We build robots because they help people. They're meaningful, they're purposeful. There's something that you're doing your creative engineering work to serve other people. And so I find that context sometimes helps. Of course, the silliness guys who want to just do lifting had trouble with this, because that's exactly where they are. They're young men who are still playing alpha male fighting, and so they're not quite understanding that the reason they do things is to help other people. So we almost got there with this stuff, but not quite. In a longer class, I would have redirected them to really do something that's that your robot helps other people. So that's where that goes. I had some videos of this. Well, a staff person at Atlas took the videos for me, and she's out, so I couldn't find those for today. I thought I was going to have them, but I could show you this. I could have showed you those things. It became a post for one of the Atlas Institute's social media that we just went up and went down for a day, so that was kind of fun. It's not particularly a charter of science discovery, but since we are teaching classes to high school kids in the Colorado area, we'd like to let them know that, hey, by the way, when you apply to college, you can go to school in your own state. Imagine that. A lot of kids got to leave home. But so we try to link it to what's going on at CU. If you like what you're doing in Science Discovery Camp, you can do a lot more of that if you were a student here. And so by doing these classes on campus, in actual college classrooms, with actual college people milling about, that plants some ideas, at least for the juniors and seniors, right? Because they'll be applying to school soon. So I find that to be a nice, what do I do next with these new skills? For elementary school kids, there's a long arc yet. This is after school, let's face it, for some parents, it's daycare. Let's keep them busy. But for high school level, you have so many things you could have been doing this summer, and you chose to do this instead. All right, I will wrap it up there. Well, one more thing. I provide some more lists of detailed additional materials if when you go home you want to build something else. So just as a starter list of what you can go off and buy. And then some resources for just robotics engineering in general, so that they can go and do stuff. One thing I would love to do, if we had time, is to have an IoT robot. So we can use the Wi-Fi board on the Bittle, connect to some cloud service, and go off and do some things like measure something, or be controlled remotely, or collaborate in some way. Too much in 1 week. But the Bittle platform, has the ability to go there, right? Not in a week, but yeah. All right, I will stop sharing and open it up for your questions and comments.
How many kids in your camp?
We did 16, kind of, the space of the classroom and the number of TAs we could have. Yeah, could do it with more. I'd want TAs that actually had the time to learn the platform. Don't always have that luxury in the way we do this class. The TAs are teaching a bunch of classes, and when will they have time to become experts in this? But yeah, you need more TAs, because when kids get stuck, if there's only one instructor and 32 kids, the chance of stuckness is high. and then you know, get yourself in trouble that you can't. Now the class is waiting for you to get back up in front and instruct. So yeah. How many classes? How many kids in your class, Elaine?
What's the TA to student ratio? Like how many students per TA?
So in this class with 16, we had two TAs. Now TAs are also responsible for some classroom management, safety, blah, 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 you know, escorting to the restrooms, that kind of thing. With high school kids, less of that, but we had another TA who didn't really know the STEM stuff that well, but he was sort of there to observe, so that was kind of fun. No, in a perfect world, I have TAs who know as much of the platform, actually more about the platform than I do. That would be great. But how do you manage that? How do you budget that? It increases the cost of the class if you have to pay TAs to learn this particular class, right? So, yeah.
And how many hours did you use to cover all that you mentioned?
How much what?
How many hours?
Oh, it was 1 week. You know, morning, afternoon, you know, about 6 hours a day with a lunch break, right?
Okay.
Yeah. And I could have done 2 weeks easily with this platform, easily. I could have done longer days, except that it's summer. We don't want to exhaust these poor kids.
Yeah, you
some
could
kids,
cover a whole semester.
Yeah, you know, some kids took the robots home at night and, you know, had to put them in a box with the rubber bands to make sure they survived backpack land. And they came back with something excited to show us. Some of them, some of them brought their robots home and then forgot to bring them to school the next day. Thanks, Mom, to the rescue. Bring the robot back. Yeah, but I love that. You know, for me, that's my greatest joy. Is on the first day of class, I've motivated, you know, some number of kids to take their kit home with them, right? Because you know that there's an opportunity for that family to have a discussion about, well, what did you do today? How was your camp? It was good. I got to show you this thing I built, and you want the family to be engaged and then to become teachers to their family, and maybe, you know, a sibling or a parent is like, oh, show me more about that. That's when we're hooked, right? That's when we've created what STEM education wants, STEAM education wants. We want to engage our family, our community, our collaborators. So at least that's how I see it. As opposed to, I teach for a public school and their STEM curriculum mandated by the state, check. That's not the goal. That's some way to get there. The goal is that we have motivated students who are now exploding with ideas that they're going to play with for the rest of their life, I hope.
So you mentioned it was, oh, sorry, go ahead.
Go ahead. Yeah, you go ahead.
Okay. I was just going to ask, so you mentioned it was like 6 hours a day for about 1 week. How much of that time was spent on the Mac?
On what? Spent on? Whoops, lost your voice. Where did I lose my audio?
Building the robot? Like, what were some of the roadblocks at that stage?
How much is spent building the robot? So it was most of the first afternoon. So break for lunch, come back and build robots. Because in the morning we were playing with robots and introducing ourselves. I had hoped we'd be all done by that afternoon. In fact, you know, we had a number of problems. We had some broken parts. You know, and thankfully, Petoi guys, thank you. You know, overnighted some parts. Kai had some parts in California he can get to us quickly. In retrospect, I should have had more spares. So that's a bit of a problem. Little tiny screws and nuts find themselves on the floor, disappeared forever. Luckily, we had a lot of spares of those. Despite telling everybody, be careful, do the work over the box that the kit came in, so when the parts fall off, they don't disappear. They don't listen, right? Some don't. But so the next morning, we sort of had to finish up the robots that weren't built yet, and that was an opportunity. Hey, if you're done, help someone who is not done. And again, you know, an opportunity for teaching, for collaboration, and you know, it would be great to coach people on how to be a helper, how to be an educator, but, you know, not enough time for that. That would be a whole nother topic. But you think about it, you know, we need to break the stereotype of engineers like, let me just do it for you. I know that. I'll do it for you. No, it's like, I want to teach you how to do it, right? And how do I communicate how to teach? This is a harder skill, right? And I think all of us are guilty of, oh, I would teach you, but I don't have the time, so I'll just do it. Here, goodbye. So that's a challenge. So you can either look at the construction as something that's delaying the actual class, or as an absolutely essential part of the class, right? The learning to read instructions, follow instructions, play with your fine motor coordination, which may not be perfect. I can instantly tell people who haven't played with Legos or blocks when they were younger, because they don't know symmetry. They don't see the construction stuff. You have to give them a step-by-step recipe. It's absolutely crazy. So, yeah. I have a whole list of. I have a whiteboard here. I can give you access to it. So you can look at it later because we're running out of time. But this was the feedback that I already shared with Petoi team. But you can. I think you should really grab an URL to this so you can look at it. But this is my successes and challenges and some suggestions and questions which we've actually answered since then. But here's some of the challenges of construction, about confusing things like orientations and wire lengths and that sort of stuff. The other thing is, I had planned to do this Arduino only, but I didn't do my homework early enough to prep for the class to realize that the then implementation didn't leave a lot of space for student sketches. So I thought it'd be too hard for this class. So I switched to Mind Plus at the last minute. And we did a little bit of Arduino. I didn't really have time to rethink how to do this as a total Arduino class, but it's totally possible. You have to, with the help of the Petoi team, figure out what chunks of OpenCat to disable so there's more room. Had some hardware failures. Not sure what happened sometimes, but figured it out eventually. Some of the kids would like to do multiple skills from Mind Plus. So with Mind Plus, you can create only one skill, but I showed them how to do it in Arduino. This was one that was interesting. When the Bittle has no battery, it tells you with some noise, some melodies, I have no battery. If 16 robots are saying I have no battery, it's quite the noise in the classroom. So it'd be nice to say, change that code to say, tell me once, but not constantly.
Yeah, that sound can be turned off with one command.
Yes. I only learned that too late. Other things I'd like to do, a platform for robots that lets me add more sensors. If people love NeoPixels, colored LEDs, addressable LEDs, doesn't have that. Lots of robots do. That's very motivating. I think for the people that have maybe an artistic sense, some kind of drama, for some reason, as exciting as legs are, these kids are really excited about colored lights, right? So that's great. It's a motivator. Anyway, you can share a link to this. I think that should be set up. So if I say share, it's shared to everybody. Yeah. There we go. Oh, here's the link. There we go. And I put that in the chat if you want to read this at your leisure. Chat. Here you go. Okay. All right. Other questions?
We can send out these links through emails later.
Sure.
And we are also thinking about making the current user community more active. And we are considering some other forms other than the forum. We have the Petoi forum at petoi.camp, but the problem is it may not be as active as we expect. And we are thinking if you were the moderator of the forum, which platform do you prefer, like the Discord, Facebook group, or Slack, or Reddit?
Boy, the challenge is there's so many of them. You know, I tend to use Discord for people who are coming from Discord as a gaming sharing weird platform. So the students tend to be more, I don't know about college students, I don't know about high school kids. So I use Discord, but I prefer Slack personally because it's a little more professional. Um, um, how do you get people to become part of an engaged community? So I showed them the forums. I said, when you take this home and you have questions, here's my email address, but even better, get involved with the forum. You know, one thing we could do, maybe it could be some incentive, you know, that Petoi could do is, you have a Petoi kit, please join the forum and in exchange we'll give you something, right?
Yeah, also
yeah, if you put, when you make your first post, you get a, I don't know, a Grove button, you know, something that costs like just the minimum postage to send out, whatever. And that would be, you know, we have to gamify things to get people engaged. It's just the way it goes, right? Because there's so much distraction. But I'd love to see those who are really motivated to become part of the forum. I haven't checked to see if the kids have done this, because after this class I went on vacation and I started prepping for my fall semester.
Yeah, we are considering like offering some coupons and give it to the forum moderator as a gift to the people who post.
That's a great idea. Yeah, the other thing is in the what next category. Yeah, you know, I'd love to see use your Bittle for your science fair project, right? And use some of the more sophisticated things, you know. And how do you get that group of kids to talk to each other, right?
Yeah. And there's the resources I want to share, like for the documentation, almost all the information technically you need to know, you can find at docs.petoi.com. And there's a very useful tool. There's a search, and there's a regular search and the lens. This lens search is ChatGPT enabled assistant. You can ask in natural language and it will answer, like, can I program the robot in Python? And it will search all the documentation, give you the answer, and give you the citation, so you can find the resources. Yeah, like this Python API. And for the curriculum, you can find it either on our official website at petoi.com or on this table of content. You can find the Petoi coding blocks with corresponding like blocks curriculum. You can download all these resources. And for the skills that students created, you may not know that we have this skill library. And it's posted on GitHub. Like every user downloading this repository can download this library, and you're welcome to push whatever your students or yourself created, and we may integrate them, we may merge them into our official site, and you can see the skills. It will have the necessary skill name, model name, your creator name, location, and data. So this functionality makes it has some property of community sharing. This skill can be imported into the skill composer to be integrated into the firmware, or can be imported by the smartphone app. And I also teach at some university. My experience, I mostly teach like a class with about 20 students, and every 2 students will share 1 robot. And for the students, they have several paths that they can create. For example, they can redesign the structure, some kind of like the structure. Or
I see. Are you showing a video?
Yes. Do you want me to shut the sharing?
No. You said I thought you would present some kind of structure.
Oh yeah, so I need to turn off the screen sharing, or you cannot see me, right?
We should be able to see you.
Stop sharing.
Okay.
Can you see me?
No, we are not. Okay.
Oh,
yeah.
no. Okay,
Yeah.
I'm back. Yeah, like this hat. This is 3D printed. Like this is our new version of the cat. Yeah, this is what they can do on the structure.
Oh, cool.
Yeah, and they can use the robot as a character to show some story videos. And they can change the program, they can change the logics, how they behave with the sensors. That's all part that you may have your students to create.
PyCat.
Yeah. And we are making some video tutorials. Let me share the screen again. Kai, do you have the video with you?
Yeah, hold on. Let me.
Oh, okay, I got it.
Why don't you share the curriculum first? Some update to the curriculum, and I will find the video.
Okay. So for this curriculum, we have the C++ curriculum and the Mind+ curriculum. Let me take the Mind+ curriculum, for example. Can you see my screen?
Yes.
A tree structure. Like this is the content we cover in this curriculum. Of course, you can tune the depth or arrangement according to your actual class arrangement, like introduction to the robotics and programming basics. It can be the syntax for C++, it can also be the blocks. And then comes to what's special for this Bittle robot, that's the multiple joint control. You can learn how to control these joints one by one or simultaneously, and how this robot can balance itself when doing all these behaviors. And then we introduce the skill composer, the tool we use to design complex movements. It's actually easy to understand. It's basically stop motion animation. Then we teach different sensors. Basically, each sensor can be one class. And the most important thing is to help the student understand how robot see the world and how to make reasonable and funny reaction, just like real animals. For example, in our official demo, we have the touch sensor in a bone shape. And if you touch one side of the bone, the robot will rotate its head, just like it doesn't want you to touch it. And this effect can be done by a light sensor too, because when you touch the sensor, the light will be blocked. So the students will realize, well, although they are different sensors based on different principles, but we can program them to behave the same. And also multiple sensor fusion, we call it sensor fusion. That means the robot behave according to different sensor, combining different sensors. For example, one student designed the logic that normally the robot will avoid you touching its bones because it's protecting its foot. But if you pat it beforehand for a few seconds, then the robot will think you are his friend, and then he will let you touch these bones. All this funny but reasonable thinking, design thinking.
Yeah, what I like about this, RZ, is students know dogs and how they behave. And now you have something you're trying to emulate by using the programming constructs. So I did not teach a top-down computer science class. I said, oh, you might want to use a function to do that, a block, or you might want to use an if-else statement. So I introduced those computer science concepts when they have the challenge of trying to emulate behavior. Very different. I was teaching a computer science class. I would do computer science first, right? Oh, we have some videos. Great.
Yeah. So this is a class I teach. And this class only lasted for 4 days. Yeah. They only have 3 days to get familiar with the system and have the team discussion and lab. And then finally, each group will make a 10 minutes demo. It's quite impressive. Of course, they are college students. Like this is doing exercises and light sensing stuff. And I actually did some background checking with the students, like how their knowledges are to different topics. And this is the statistics. Like most of them are quite familiar with C++ and a little Python and some hardware electronics. And they are second-year college students. Yeah. And for the class, in my arrangement, like the first 2 days will be the introduction to robotic sensors and set up the robots and coding environment. But this class is mostly in Arduino because they are familiar with C++ and some sensors. I only taught them 2 or 3 sensors, basically how the data are presented and calculated, and then they will design their own. So for other people attending this meeting, have you already tried Bittle? And have you got any interesting projects that you let your students do? Not yet?
Okay, let me share the video we are working on. Let me do a screen sharing.
Actually, I got it. I can
Oh,
play
you
it
got
on
it.
my side.
How to have Bittle to greet people. There's 2 ways of doing it. We can use the sequence of blocks to make Bittle execute several skills. Sit, hi, and stand up. Run the code. Now we know that Bittle is connected and also working the right way. But to make 3 coding blocks into 1, we can export our skill from the skill composer. Make sure the gyro function is in the deactivated state to prevent the robot from performing real-time balance feedback actions. Since the first step to greet people is to sit, we can use one of our preset postures, sit, and make sure to click on exclamation point to save the frame. Then add a second frame. Adjust the red front arm to -99. Move the head towards you at -25. Save and add another frame. Adjust the right knee to 0. Click Save and then repeat the process for 3 times so that Bittle is waving. After the whole skill is complete, go back to Mind+. This time we only need 1 coding block instead of a sequence of coding blocks. Perform the skill exported from Skill Composer and delay 0.2 seconds. Now we can go back to Skill Composer and export our skill. Go back to Plus and click Run. Bittle has performed the skill successfully.
So this is a video for one of the chapters in our block-based coding curriculum. we are going to develop a series of videos to basically walk through all of our curriculum content for the block-based programming.
So one thought, if this was a 4-credit class where I can assign homework, this would be a great example to use the flipped classroom approach, right? So homework tonight is to watch these videos, and then tomorrow in classroom we're to start right away programming, and then when you get in trouble, your instruction, your TAs are available to help you, but we don't have to spend the time in the classroom watching the video. And what I love about that is not everybody absorbs the instruction at the same pace. So you could, for homework, watch the video, ask a few questions. If you're not sure, go watch it again. Watch it at 0.5 speed, right? So that's a really wonderful addition to this. Not so much for a summer camp, but for a semester level class. Fantastic.
Thank you.
Each video will be very short. Like we want to make it within 2 minutes, so that people nowadays lose their patience very quickly.
Exactly.
Yeah. So we are about to run out of time. Anyone have any final questions?
Well, I just want to say that I am absolutely glad to meet with any other STEM educators that are considering Bittle or developing curriculum and want to collaborate on ideas. I'm available. I'll leave my email in the chat. Or we can somehow meet on the forum. That would be great if that happens. Colorado.edu. Yeah, happy to meet people and discuss and brainstorm your ideas on how do we improve how we do STEM education with these extraordinary platforms. So I really thank the Petoi team for building a cool product, and wish you guys every success as you continue to develop the product itself and the associated curriculum and documentation. It's really, really quite an achievement.
Do you have questions?
Yeah, actually, just heard Professor William, you mentioned about for elementary school student, the after school program and the camp, because I try to host some like after school program and camps for primary school students from grade 2 to grade 5. I also found that it's kind of difficult to get them focused to the programming part. They are too active. They like play with the dogs, which make the dogs more like a toy. But I want to find a more kid-friendly way, like they can find it more convenient for them to learn programming and can really have fun about it. I know that's not easy. That's a lot of work, but I'm just trying to find how to make it more convenient for grade 2 to grade 5 kids to play with the Petoi and learn programming thing.
So in my experience for elementary level kids, this is way advanced for them. Also, it's pretty fragile for kids who just don't respect, these things. I forgot the name of it. Ozobots. I just remember Ozobots. So we have some Ozobots. They're little tiny things, and fit 5 of them in your hand, and they have wheels and light sensors, and you program them with colored pens. So they will do line following, but you put colored marks on the line that makes them turn left or make a noise or spin around or stop or reverse. And this is really fun and requires no computers, just colored pens. And you can create races, you can create challenges for them. And this can set them up for the next step, which is to program a real robot. Nothing's real, right? But things that are sort of indestructible. And they're self-contained, not really computer things. Because elementary kids and computer screens, it's hard to keep them attached to them. So a lot of the kids that have come into my camp in junior, middle school or high school have already been in previous camps and they've played those kinds of things before, so they have this concept. The ones who don't, it's a challenge. So when I say, make the robot go in a square, and they're not sure what to do, right? So I have them, okay, I am the robot. Tell me how to go in the square. Yell out my commands. Walk forward. And I walk and I hit the wall, And wait, let's start over again. Walk forward. Stop. Okay, turn right. So I turn right in a circle and keep on going. So they have to tell me, go forward, stop, turn right 90 degrees. Repeat that 4 times, 3 times, right? 3 more. And so they can learn that skill earlier with simpler toys. Right? If they've never done it, I become the robot for them, because you know how to do this. The programming languages get in the way of what you already know how to do. We have to have that gap. So there are robots that are more toy-like that teach them these programming things. Trick them into learning programming. Right? That's really what we said earlier. Right? You didn't know this was a programming class. So that's my approach, and that's why there's a whole range of things that are useful to play with. And they're expensive, unfortunately, right? How do you outfit a classroom, keep them working, keep the batteries up to date? They fail over time. So it is absolutely a challenge.
So for the instructions you just mentioned, like walk for a few minutes, for a few meters and turn 90 degrees and loop 4 times, all these instructions are possible to be sent to the robot with the help of ChatGPT, and we are considering to add that interface too.
Oh, that's great. Thank you.
Yeah, and I think for little kids, they're not quite ready yet, but some of them may be, right? So you can start with something simple to play with. You have the budget for a classroom to have some other robots to play with. And that's even what I do with my high school kids. I had them play with a bunch of robots to sort of get them thinking about what are the things. Actually, the end of the play is a discussion. What is a robot? Right? What are the things you observed? And I want them to build this model of inputs that sense environment, outputs that interact with the environment, and then the box in the middle, right? Which I want to call logic or programming, whatever. I let them come up with a name for it. My favorite was Thinky Bits. And throughout the week, people would say, oh, there's a problem with your Thinky Bits. Right, but I let them build that model by observing the robots we're playing with, and then categorize their observations into these 3 buckets, right? And that can be done at any age, really fine. Let them use the terminology that makes sense to them.